Good afternoon friends, welcome to the next e-lecture of JC E-Connect series. Today we will be discussing the next part of your module 2, that is losses in prestress. So what is exactly loss of prestress? It is a process in which gradual reduction of initially applied prestress takes place over due course of time. That means the initial prestress which you are applying, gradually the effect of that prestress reduces, or the amount of prestress which we are applying gradually reduces with time, which is termed as losses of prestress. Now as a engineer we need to estimate this loss because it has to be considered in the design, as well as we should be aware of the causes and the nature of the losses, because few of the losses can be prevented by taking the necessary precautions during the execution stage. So it becomes very important for a civil engineer to know the causes and the nature of the losses. So losses in pre-tensioning. Pre-tensioning, which you have studied previously, if we go for pre-tensioning process, okay, the PSC members can undergo 4 types of losses, which are elastic deformation of concrete, relaxation of stress in steel, next is shrinkage of concrete, and the last one is creep. Now if your member is post-tensioned, the elastic deformation only occurs if the prestress force is not induced in the wires simultaneously. If you go for simultaneous tensioning, the elastic deformation does not happen in post tensioning method. So if you are on the site, you need to observe that whether the process of tensioning is done single wire wise or it is done together, because it will result in elastic deformation. Next is relaxation of stress in steel, shrinkage of concrete, creep of concrete. These 4 are nearby the same in both. The fifth one here for post tensioning is friction, and the next one is anchorage slip. Okay, so when we come for post tensioning, we are getting 6 types of losses, whereas in pre-tensioning we have only 4 types of losses. So now let us start with discussion of the first type of loss. Okay, so in addition, if you go for say steam curing, especially in pre-tensioned units, it also may undergo some losses. Now see here friends, such things can be your seminar topics, because we have never seen here steam curing. What we know is a regular curing, okay, which we see on the site or in the experiment in your laboratory. You do it with the cubes which you immerse in water. So steam curing is a type of curing which is now regularly used on bigger sites, but we don't know its exact application. So such things can become your seminar topics. Many of you all ask suggestions for picking up seminar topics. So from a subject learning itself, you can get a hint of new techniques. We cannot say it new, it is new for us as we have not applied it. So let us start with the first loss, that is elastic deformation of concrete. So what is elastic deformation? It is a change in shape due to the application of loadings, or variation in shape is termed as elastic deformation. Till the deformation is elastic, it means that it can regain back its original shape and size once the loading cycle ends. So what happens here in concrete is, concrete undergoes elastic shortening when pre-stress is applied, and as a result of it, simultaneously shortening of pre-stressing steel also takes place, which results in losses. Now mathematically we can find the loss by using the formula. Say if delta is the loss, delta is equal to m into Fc, where m is the modular ratio, that is elasticity of steel to elasticity of concrete, and Fc is the prestress in concrete at the level of steel. Again I am repeating, Fc is prestress in concrete at the level of steel, means where the steel is there or where the reinforcement is placed, at that level what is the prestress in concrete. So Fc is given by the equation P by A plus Pe by I into, instead of y, here again once again eccentricity E we have to take. Next factor is relaxation of stress in steel. Now relaxation is assumed as a loss of stress in steel under constant strain at a constant temperature. Now strain is what? Change in length upon original length. So when steel is subjected to a constant strain and a constant temperature, there are losses due to relaxation of steel. It is somewhat similar to the creep in concrete. The losses due to relaxation vary widely with different steel manufacturers and different grades of steel. So here the steel manufacturers and the process of manufacturing comes into picture. That's why when we take steel or purchase steel, knowing the manufacturer becomes very important. It is not only the grade which is important, it is also the manufacturer from which we are purchasing steel. So currently Tata is one of the leading manufacturers because it gives the best possible quality of steel. So similarly other manufacturers are there, Jindal is there. Okay, so we have various manufacturers, so you should know the manufacturing process as well as the quality of steel. That's why many times these bigger companies take the leading engineers, structural engineers of a city for their plant visit, so that they can understand the process of manufacturing and what are the things they are following and how best quality of steel they are producing. Okay, so here manufacturing process also comes into importance. So generally the losses vary from 2% to 8%. So the losses are found by sampling data or testing data, and generally for this 1000 hours of loading under at a temperature of 27 degrees is considered to get this data. So relaxation of stress in steel will be directly in the form of percentage if it is to be applied in the problems. Next comes is loss due to shrinkage of concrete. Shrinkage is defined as change in volume of concrete members. Okay, now the volume of concrete changes, which results in shrinkage, which further results in losses of stress. Now it is dependent on mainly humidity, as well as you have methods of curing, you have type of cement and aggregates used, whereas it is not directly dependent on the application of loads. The primary cause of dry shrinkage is progressive loss of water from concrete. So if the curing process is not that great, water escapes out from concrete and this results in shrinkage, and shrinkage further results in loss of prestress. Now when you go for high strength concrete in PSC, what happens is in high strength concrete, and if you go for accelerated curing, first of all the high strength concrete has a reduced water cement ratio. The content of water is lower in the concrete produced, which will easily undergo shrinkage if proper measures are not taken, and if it undergoes shrinkage easily, it results in considerable losses of prestress. Next, in case of pretension members, generally moist curing is resorted in order to prevent shrinkage until the time of transfer. So in pretensioning the care is taken and the members are kept moist throughout. I think if you have observed near third gate, the beams which were casted were covered by gunny bags which were wet. if you have made an observation while passing by your third gate area, you will come to know this easily. So how we estimate the losses due to shrinkages? A easy formula, epsilon Cs into Es, where Es is modulus of elasticity of steel and epsilon Cs is total residual shrinkage strain, and values are different for pre-tension and post-tension as given below. It is as per your IS 1343/1980. The term small t refers to the age of concrete at the transfer stage in number of days. So with this we will conclude today's discussion. We have discussed three factors which will affect or which cause losses of prestress. In the next class we will discuss the further three causes and go ahead with the problems. And thank you for your valuable feedback, and I will take care that the things which you have suggested will be followed in the upcoming lectures. Thank you.